The intention of this video is not to provide instructions on how to install microduct or microcable. It represents a real-life installation that illustrates the overall technology. There are many variations in the practices and equipment used in these technologies that will also result in safe and effective installations. What you will see is AT&T's installation of OFS's MiDia FX Plus optical fiber microcable into their network in Atlanta, Georgia in February of 2004. AT&T had previously installed 15 miles of microduct and OFS's MiDia FX Plus microcable into their Atlanta network. This installation represents the final 1,000 feet of that build. The installation started at this handhold, where you can see the existing 1.5-inch conduit as well as the end of the previously installed microduct and microcable. As was done in the 15-mile route, they intend to install 6 1210 microducts into one of the empty 1.5-inch conduits, and then install OFS's microcable into one of the microducts. Typically, the microduct is run from one handhold to the next, and then are coupled together in each handhold in preparation for installation of the microcable. In this instance, the microduct and microcable were only blown from one handhold to the next. The conduit was pre-lubricated before the microducts were installed in order to ensure minimum surface friction. The lubricant was spread down the length of the conduit with the aid of a foam plug, generally referred to as a pig, which can be pulled or blown through the conduit. The blowing machine that was used to install the 6 microducts has a hydraulically powered tractor belt that provides the initial pushing force and maintains a controlled speed for the installation. Compressed airflow from a pneumatic compressor was also channeled through the machine and into the conduit, helping to float the microducts within the conduit and provided the main pulling forces that installed the microduct. The 6 microduct reels were loaded onto payoff stands. The end of each microduct cable was then fitted with a pneumatic valve that was used to pressurize the individual microducts during the installation. The lead end of each microduct was then loaded into the blowing machine. Due to the short length to be installed, the approach taken in this installation was only to run 4 of the microducts through the blowing machine. A short piece of conduit was used to couple a Y-block to the front of the blowing machine. The remaining 2 microducts were brought together with the 4 going through the blowing machine at the Y-block. Since the airflow inside the conduit greatly increases the pressure on the microducts are pressurized to ensure that they do not collapse during installation. Here you see the lead end of each microduct being sealed with a screw-on fitting. In this particular installation, the lead end of each microduct was attached to what is commonly called a missile. The missile restricts the airflow at the lead end of the microducts, inducing a pressure differential that can help provide an additional pulling force during the installation. After the missile was attached, each microduct was pressurized with air from a pneumatic compressor. A length of 1.5-inch conduit was coupled onto the end of the conduit used, extending it up to the front of the Y-block. At the beginning of the installation, the microduct was pushed only by the tractor motor. After 100 feet or so, typically enough surface area of microduct has been installed to enable an airflow that will provide a sufficient pulling force. At this point, airflow was introduced into the conduit through the blowing machine. Installation speeds of microduct typically range from 120 to 150 feet per minute. After the microducts were installed through the length of conduit, the tractor motor and airflow were stopped. The microducts were removed, depressurized by removing the end plugs, and were cut to the desired length. The OFS cable installed was the coiled 1,000 feet or so remaining from the previous installation. In some cases, a different blowing machine is used to install the microcable into the microduct. This machine used an electric-powered drive wheel and compressed airflow to install the microcable. Generally, the end of the cable is either attached to a small missile or is simply fitted with what is usually referred to as a bullet, which provides a tapered end to ease movement through the microduct. The microcable was loaded into the blowing machine. As with the microducts, the microcable was initially pushed using only the drive wheel, with compressed airflow being introduced after the first 100 feet or so. Typical installation speeds for OFS's microcables are 180 to 260 feet per minute, up to distances of 6,000 feet. In this case, the 1,000-foot length of microcable was installed in 7 minutes. After the desired length of microcable was installed, the drive wheel and compressed airflow were shut off, the microcable removed from the machine, and the excess cable was coiled and placed inside the handhold. This concludes the demonstration of the February 2004 AT&T installation of OFS's MiDia FX Plus microcable.